Hello from Saarbrücken. Okay, so our study is broadly a replication study on dependency length minimization, or DLM. To recap, dependency length minimization is the use of word order to minimize distances between dependents and their heads in a sentence. It's widely seen as a universal, for example, being observed in all languages in a sample of 37 by Futrell et al. In 2015, whose study we broadly replicate here. However, there are nuances, one of which is that this effect appears to be less strong or even absent in verb-final languages. It's also recently been proposed by Yadav et al. That dependency length minimization arises rather as a secondary effect of minimizing intervener complexity measure, which is the number of syntactic heads between the dependent and its head. Both of these measures are illustrated at the bottom of this slide. The illustration taken from Yadav et al.'s paper on the subject. Another thing we're interested in is corpus choice. Most previous studies use universal dependencies corpora, which have several advantages for cross-lingual comparative study. They have high-quality manual annotation, cross-lingually consistent annotation, and quite wide language coverage. There are drawbacks though. Domain and content can vary a lot between languages in UD. For example, some are mostly news text, others mostly poetry or epic prose, and so can the data sizes. In other words, could these differences be confounding results? And this is a wider question in quantitative typology. An alternative is to use parallel corpora, such as parallel universal dependencies or parsed Bible corpora. And this has advantages. Parallel sentences are more comparable in structure and content, and we balance data sizes. But we also often get narrow language coverage or small corpus size in the case of, for example, parallel universal dependencies, or highly specific lects that don't really reflect common language use in the target language, for example, in parsed religious texts. Which brings us to our corpus. We pilot a corpus called CIEP+, which is a parsed collection of translations of modern prose. It covers 37 languages so far, of which 30 Indo-European and 7 non-Indo-European, but it's growing. And the intuition here is that prose is usually translated to entertain, so we can expect more natural sounding translations in the target language than we would get from some other translation sources. There are still drawbacks, so we may still have translationese in the corpus, for example. And it also limits us to the set of languages in which these translations can be expected to be available, which are mostly the so-called LOL languages, large, online, lots of users. But we do think this is a real step forward in being able to use parallel corpora in cross-lingual studies. So our experimental setup broadly follows that of Futrell et al. 2015. We compare dependency lengths in sentences in 35 languages in CIEP+, to baseline permuted versions of these sentences. We measure the rate of dependency length increase for each baseline, that is how dependency length increases with sentence length. And we follow the same method for measuring intervener complexity measure. These are the permutation methods we use to produce these permuted baselines. Random free and random fixed produce random permutations of sentences with either free word order or a fixed word order, according to a randomly generated grammar. Optimal order is based on Gilder and Templey's algorithm for finding the free word order permutation of a sentence that minimizes dependency length. Fitted grammar, which is introduced in this study, permutes sentences with a fixed word order based on majority counts in the corpus. And this gives us an idea of how much dependency length minimization is achieved by canonical word order. And this is how we get the rate of dependency length increase. We use a linear mixed effects regression model to find the coefficient for the increase in dependency length as a function of sentence length, with the sentence ID as a random effect. The higher the coefficient, the greater the expected dependency length. We find this for each of the baselines and for the original order, as shown in the graph on the right. So what were the results? Well, first of all, we do see dependency lengths of original order sentences well below the random free and random fixed baselines. And this is in all languages. So that's a good indication this is universal. But we do also see this rising tail on the left, which is made up of verb-final and V2 languages. And that shows the dependency length minimization effect is weaker for these languages, as other researchers have found. The optimal order baseline here is consistent between languages, and this shows us that this effect is not caused by any inherent complexity in the structure of the sentences. The fitted grammar baseline also shows dependency length minimization in most languages, but it's still higher than original order. And this to us indicates that word order freedom or variability is also playing quite a significant role in dependency length minimization. So how about intervener complexity measure? Well, not only is it below the random baselines here, but it's actually in some cases close to or even below the optimal order baselines. And this was quite surprising. It may tentatively be evidence that the original order sentences are optimized for intervener complexity more directly than dependency length. But the optimal order algorithm doesn't optimize for ICM directly. It's possibly applicable, but it optimizes for dependency length. So we'd be cautious about this conclusion and probably recommend further investigation. But once again, we do see the same rising tail on the left, which shows that there's the same asymmetry for intervener complexity measure as well. So there have been some interesting and surprising findings here, but broadly our results mirror those of Trell et al. And others who have worked with universal dependencies instead. One interpretation is that dependency length minimization is so prevalent that it shows the noise of domain variation, or that it's actually present in every domain. Another is that we're looking at languages as a whole here, and so sentence variation averages out. So in this study, both universal dependencies and CIEP+ will show the same results. But we think there will be studies where parallel corpora will be more important, and those are studies targeted towards particular construction types between languages. And I think that's the direction that we're heading in next. So to conclude, we uphold dependency length minimization as a universal in our study on the parallel corpus. We see the same asymmetry in verb-final languages in our parallel corpus. We see dependency length minimization is achieved in part by both canonical orderings and word order flexibility, judging by the behavior of a fitted grammar baseline. And we see a very similar pattern for intervener complexity measure, but tentative evidence to suggest that this may be closer to fully optimized in real sentence orders. We hope to use CIEP+ in future studies of this kind to great effect. Thank you very much.